So now that we have learned how to differentiate using the sum rule and the power rule, and if you haven't checked that out, I suggest you checking the previous video. We will go on to describe on how to differentiate even more complex functions. The first rule that we will be talking about today is the product rule. The product rule states that, let's say for a function f of x equals to x squared multiplied by x plus 1, you must classify the first term as u, second term as v. And in this situation, what we have to do, if you take the first term, u, then differentiate the second term, dv dx, and add, and take the second term, and differentiate the first term, du dx, v du dx. Right, now how do we put this into practice? Okay, now that we have to take the first term, x squared, then we differentiate the second term, x plus 1, which is just 1, plus we take the second term, x plus 1, multiplied by by differentiating the first term, 2x. What this gives us is x squared plus 2x squared plus 2x, which we can further simplify to 3x squared plus 2x. And since x is a common factor, we can factor it out, x 3x plus 2. And there you go. dy dx equals to this. Now, moving on, we'll be going to talk about the... Before we move on, we have to understand that the product rule is we use it when we have to differentiate a function where there are two or more variables, or you can say multiplied by each other. Now that we move on to the quotient rule, in this situation, we use it when we want to differentiate a function that is dividing each other. For example, f of x equal to x squared divided by x plus 1. Just make it as simple as possible, right? In this situation, how do we differentiate? We have to use the quotient rule, which states that we take the bottom part, v, we classify this as u, then this as v. Take v, then we differentiate the top part, du dx, then minus taking the top part, u, and differentiate the bottom part, and then you divide by v squared, which is the bottom part squared, v squared. Applying it to this question, first, how I like to solve the question using the quotient rule is to basically first list out u and v. So u equal to x squared and v equal to x plus 1. Then I like to list out their differentiated components, which is u prime, 2x, v prime equals 1. Now, we can just input into this function, right? So, x plus 1, v, take the bottom part, differentiate the top part, 2x minus u, the top part, x squared, multiplied by the bottom part, the derivative of the bottom part, which is 1. And then divide by x plus 1 squared. Now what this gives us? Well, you could simplify 2x squared plus 2x minus x squared over x plus 1 squared equal to x squared plus 2x divide x plus 1 squared. We can be further simplified, factor out x plus 2, x plus 1 squared. And that's it. This is your dy dx. Now, moving on to the last one for this video. and that is the chain rule. In the chain rule, we use it when we want to differentiate a function where there is the underlying function within itself. For example, f of x equals to x plus 5 to the power of 5, right? So now let us define, in this situation, let us define x plus 5 equal to x, right? Then now what we have to do, if we take the outer part, we differentiate the outer part of the function, right? So outer part of the function, x power 5. We differentiate this part. Then after that, we multiply by the differentiating the inner part, x plus 5. Okay, to apply it to this situation, right? How do we apply? Now, we differentiate outer part, so we get 5 x plus 4. No, let's maintain the x, right? So we differentiate outer part, 5x4. Okay, we differentiate and we get 5, bring down, maintain the inner part, minus 1, 4, multiplied by differentiating x plus 5, which get 1. So your answer is 5x plus 5 power of 4. And that is your final answer. Don't worry if you still don't really understand it. We'll be going through some questions below. Right. Now, in this situation, we have the function dy y equals negative x power cube multiplied by 3x4 minus 2. Okay, how do we do it? Simple. Remember, dy dx, this is the product of each other. So we have to classify u equals negative x3, v equals 3x power 4 minus 2. Now we get the u prime, which is negative 3x squared, and v prime equal 12x power 3. Right. Now remember, we take the first part multiplied by the derivative of the second part, 12x3, plus take the second part, 3x power 4 minus 2, and derivative of the second part, negative 3x squared. What this gives us is dy dx equals to negative 12x power 6 plus negative 9x power 6, negative positive. Right. Let me further simplify. And get negative 12 minus 9 equals negative 21x6 plus 6x squared. And since, let me check. There's the common factor of x squared and 3, so we can take out 3x squared negative 7x4 plus 2, and that's will be your final answer. For the next one, remember, it's a bit more complex, but we can do it. Alright, u equals negative 10x squared minus 7. Okay, I want to make it into another more simpler form, 2 power 5, 2 over 5. Because remember, the square root of x equals x power half, and the fifth root of x squared is equal to x 2 over 5. Right? Now, continue, plus 9 2x, okay, that is for u. Then for v, you get 6x squared, and that's it. Because 4 is a constant, we can cancel it out. Then, sorry, wait, 2x3 plus 4, my bad. Right, then u prime, -7 multiply 2 over 5, you get -14 over 5, x. Then 2 over 5 minus 1, you get -3 over 5, and that's it. For v prime, you get 6x squared. Yeah, and that's it. Right. Now, remember, take the first part, differentiate the second part, take the first part, differentiate second part, plus take the second part, differentiate this first part. Divided by second part. Sorry, my bad. That's it, right? And now, if you want to simplify it, you could simplify, but it'll probably take a bit of time, so I won't be really going through this in the video, but you can take your time to simplify it. But that is really the gist of using the rules, right? Now, moving on to the quotient rule. So, remember, list out u as 4x3 minus 3x squared, v equals 4x power 5 minus 4, u prime right. Now, remember the rule? We take the second part, 4x power 5 minus 4, then differentiate upper part minus taking the upper part multiplied by the differentiating the bottom part divided by the bottom part squared. Or we forget to write the dy dx symbol. Okay, now you can, since you don't need to really expand first, what you can do, wait, let me see. Maybe you can expand, right? Let me try. Get a bit tricky. You can take your time to expand this because it's really going to take a lot of time and I don't want to spend too much time on this video. Alright. Same rule applies for the next question. We want to differentiate it. Remember, take the bottom part, multiply by the derivative of the top part, minus top part, multiply the derivative of the bottom part. And then we take the bottom part square. And as always, you can take your time to solve this because I really don't want to get too long into this video. moving on, we have this function, right? So in this situation, we have the inner function, which is x power 3 plus 3, and the outer function is x to the power of 5. So we take the outer function, dy dx equals to 5, then maintain the inner function, then power 4, then multiply by the inner function itself with 3x squared, right? This will get you 15 x squared x power 3 plus 3, 4. And there you go, pretty simple. Now for this, a bit more complex, right? So we have the inner function, which is this part, then we have the outer function, which is cube root, right? So let us write it in a more easier way first. In a ready form, 3. Remember, cube root of x equals x to the power 1 over 3, right? So differentiate f prime x equals to, bring down, maintain inner function, plus 5, then 1 over 3 minus 1 equal to 3, then multiply by the inner function as well. The derivative of the inner function. And there you go. That is the answer. Right? So that's it.